In the last video, we developed the formula for compound interest, which is given by A of t equals P, the principal, times 1 plus R over N, the annual interest rate divided by the number of compounding periods per year, all to the nt power, where t is the number of years, the amount of time that the money is invested. Let's go through a problem and look to see how we can use this and compare what happens depending on the compounding periods. A sum of $1,000 is invested at an interest rate of 12% per year. Find the amount in the account after 3 years if the interest is compounded annually, semi-annually, quarterly, monthly, and daily. What we're going to do is we're going to make a table and do the calculations for each of these compounding periods. So first, we need to write each compounding period. And so we've got annual, semi-annual, quarterly, monthly, and daily. Now for each of these, I want to write out what n is. Remember, n is the number of compounding periods per year. So if it's compounded annually, that's just 1, because it's compounded at the end of the year. If it's semi-annually, that'll be 2, once after the first 6 months and then once after the second 6 months. Quarterly, n is 4, because there's 4 quarters in the year. Monthly, n will be 12, because there's 12 months in the year. And daily will be 365, because there's 365 days in a year. We will not put 366 to account for a leap year or anything like that. We're just going to assume that there's not a leap year. In fact, in some situations, they use 360 for daily, because it is a more round number to use, but we're going to use 365 to do the actual calculation. And then for each of these, we have to determine the amount after 3 years. So we're going to use this formula, and we're going to set it up for each of these situations, and then use a calculator to do the calculations. So for annually compounded, the principal is 1,000. In fact, that's true for all of them. And then we have times 1 plus R over N. The interest rate is 12%, which is 0.12. And the number of compounding periods, N, is 1. And then this is raised to the N times T power, and that's going to be 1 times 3. And we're going to do this for all of the different compounding periods. So for semi-annual, we still have 1,000 times 1 plus, and we're still going to have 0.12, but in this case, the denominator is going to be 2, because we've got 2 compounding periods, n is 2, and then the exponent is going to be 2 times 3. The number of years stays the same, but the number of compounding periods change. In fact, for each of these, the only thing that changes is n, which appears twice in each of these expressions. So let's do the rest. We're going to have 1,000 times 1 plus 0.12 over 4 to the 4 times 3 power. And then for monthly, 1,000 times 1 plus 0.12 over 12 to the 12 times 3 power. And then for daily, 1,000 times 1 plus 0.12 divided by 365 to the 365 times 3rd power. And we can use a scientific calculator to evaluate each of these. Make sure that you're entering everything into the calculator, like so. You're going to need parentheses in here so that order of operations is followed. And for the exponents, I would actually recommend either using parentheses around the whole thing so that you make sure the whole product becomes the exponent, or just doing this calculation in your head and entering in exponents of 3, 6, 12, 36, and whatever 365 times 3 is. I don't want to do that off the top of my head. Anyways, when we enter these expressions into a calculator, we get the following results. $1,404.93, $1,418.52, $1,425.76, $1,430.77, and $1,433.24. We can see that the difference between annual compounding and daily compounding would give us almost an extra $30. Now that might not seem like a huge amount of money over the course of 3 years. However, if we're looking at larger investments, for example, the investments that a retirement fund for an entire corporation might use, having different types of compounding, specifically compounding more often, ends up earning quite a bit of money. So if you're looking at 2 investments and one of them is paying interest annually and the other is paying interest quarterly or monthly, you could earn a decently larger amount of money if you pick the one that is compounding more often. Of course, if the interest rates are different, you've got to go through and compare those to figure out what's really the best. But I just want to point out that as we have interest compounding more often, the amount of money that we earn ends up being larger. In the next video, we're going to look at what happens to these values as we compound even more often than daily. We could compound hourly, or by the minute, or by the second, and we're going to see that there is a limit to the amount of money that we can make. This is not going to be increasing forever. In fact, you can see that the amount that these increase by gets smaller and smaller each time we move down, and there's going to be a limit, and this is going to correspond to continuously compounded interest. And that's what we're going to look at in the next video.